All right, welcome to the calculator inactive section of this FRQ practice. We're going to take a look here at FRQ 3. Always start by reading the question. Mr. Passwater's wife wanted him to purchase a Roomba that would vacuum his living room automatically each day. However, he found a deal on the internet and purchased a Roomba instead. The Roomba does not operate properly and travels only in a circular path, completing one rotation every 15 seconds. Point B is on the edge of the Roomba and is located directly above the center of the circular path at time t equals 0, as indicated in the figure. Point B is 5 feet from the center of the circular path and 1 foot from the wall at time t equals 0. As the Roomba travels at a constant speed, the distance between B and the wall periodically increases and decreases. So we got to be able to pull out some important information here. So even when the Roomba is right here, it is exactly 1 foot from the wall. Also important information here is 5 feet from the center. So this circle has a radius of 5. So we have to think, okay, I'm just going to think for a second here. I have this point. Well, we're 1 foot from the wall here. But what about when we're right here? This is the furthest it gets from the wall. Well, it's 1 foot plus 5 foot. But then this is a radius, so it's another 5 feet. So the furthest the Roomba gets from the wall is 11 feet. Well, what about these points right here? Well, it's 1 foot, then 5 foot, so these are 6 feet. And so you can kind of see this function. Here's the minimum distance from the wall. Here's the maximum distance from the wall. And here's that midline at 6. And so FRQ3 will always start where we got to fill out something like this. And this one is a little bit tricky because I'm tempted to call this time 0. But it's not, because F is clearly at a maximum distance from the wall. So, if I'm starting maybe down here, because this would be a minimum distance from the wall at, 0, 1. There's this point that's not on there. Okay, well, we go halfway around. We start here, and we go, it takes 15 seconds to go all the way around. So you have to think, how long does it take to go halfway around to get to this point F here? Well, half of 15 is 7.5. So this first point is really, that we are labeling, is happening at 7.5. And how far away is that? Well, that is 11 feet away. That's a maximum. Now, there is some variance. If you started this at 0, it's not necessarily wrong, but you just have to make sure that this is 11, because it is a maximum. Well, then we reach the midline here at G, and you have to think, okay, so I go around another little bit. I'll just show this in blue until I reach this midline here. So now I've gone from 7.5, I've gone another fourth of the way around the circle. So, well, I don't know. Actually, sometimes it's easier to fill out the mins and the maxes first. So let's continue all the way around the circle until we get to here. Well, now I'm the minimum distance that I get from the wall, which is 1. So I know point J is something, 1. Well, I went halfway around the circle, so this should be 7.5, 1. Here I reach another, or not 7.5, 15, 1. And I could have here, I go, okay, well, another 7.5 seconds to reach another max. 22.5, 11. So what's in between these? Well, halfway between 7.5 and 15. What is that? That is, my brain's not working today. 22.5 divided by 2 is 11.25. So this is 11.25, 6, and halfway so it's going up by 3.75 each time, so this is 18 0.75 comma 6. Some of you are not good at fractions and decimals. You might struggle with this. Now, this is just one version of the correct answer. Your t values, your input values can change. So, but these cannot change. So, another version of the correct answer is you could have said, okay, this is, I'll write these kind of small and I'll write them in pink. I don't know. Okay, so the other, I could have said, okay, 0, comma 11. And so I'm here, 0, comma 11, and I go a fourth of the way around the circle. So really, the way I'm getting these fours is 15 divided by 4 is 3.75. So every time I go a fourth of the way around the circle, so these would work as well, these answer choices. So this would be 7.5, comma 1. This would be 11.25, comma 6. And then this would be 15, comma 11. Both of these are possible sets. And we'll look at the scoring rubric in a second to talk more about that. Okay, so let's talk about B. Oh, we have a cosine function. Be careful. We have a cosine function here. So let's be careful with that. We need to find A, B, C, and D. All right. So where do we have this cosine function? Well, A is the amplitude, which is equivalent to the radius, so that is 5. And D is the midline, which is 6. A and D are always pretty easy to get, and getting them together is worth 1 point. B, to find B, that is the period equals 2 pi over B. Well, the period here is it takes 15 seconds to get around. So I'm going to say 15 equals 2 pi over B. I get 15B equals 2 pi. Divide by 15. And B is equal to 2 pi over 15. Now, remember, the cosine starts at a maximum, so I start here at a maximum at 7.5, comma 11. So we went 7.5 to the right. So because, we're starting here at 7.5. So how do we go 7.5 to the right? Well, I guess it could be plus or minus 7.5. So this could be plus or minus 7.5. Because if you also could go 7.5 to the left, you'd be back at where you started. We're going to go with plus 7.5. Because cosine should start at a maximum. Well, really? No, plus or minus. All right, we'll come back to that with the scoring guide. Okay, even if you really struggled with this one, everyone should always get C correct. Everyone. From G to J. Those are the points that we're looking at. So let's come up here and let's look from G to J. I'm actually going to use blue. So from G to J, what is it? Well, it's positive because it's above the x-axis. If the y values are positive, it's positive. So I already know it's not negative. The y values are positive. And is it going up or down? Well, it's clearly going down. So it's positive and decreasing. All right, on the interval T1 to T2, describe the concavity. Well, this is clearly concave up. And determine the rate of change. If it's concave up, it's automatically increasing. So on the interval T1 to T2, the graph, just answer this in a complete sentence. The graph is concave up, and the rate of change is increasing. Make sure you say the rate of change is increasing. Don't just say the function's increasing. The function isn't increasing, it's going down. But if a function is concave up, then it is automatically has an increasing rate of change. All right, let's look at the scoring guide because I was a little messy on this one. Okay, so here we have the values that I wrote. Did I write 11.25 or did I write? Okay, I did. I thought I might have messed that up. All right, so, but notice it says T coordinates will vary. A correct set of coordinates for one full cycle of H is pictured as pictured is acceptable. So if you need feedback on if yours is correct or not, let me know. You get 1 point for the correct output and 1 point for correct input. So even if you just got 11, 6, 1, 6, and 11, that's a full point. If you got inputs that make sense, even if they're not the exact inputs I showed, those would also get you a point. Okay. For this part, you always get a point if you get the vertical transformations right, A and D, and a point if you get the horizontals right, B and C. So we got A right, that's the amplitude, that's 5. We got D right, that's the midline, is 6. We got B correct, which is 2 pi over 5, or sorry, 2 pi over 15. And C, negative 7.5. Yeah, you could have, well, yeah, plus C. So you could have also had a positive 7.5, like I was saying. Either of those will do. Based on, there are other correct forms. So see, there are other correct forms based on shifts. This is where AP readers are trained to find all of the correct forms. All right, this one is easy. It says answer choice B. If you got it right, you got it right. And the graph of H is concave up. The rate of change is increasing. These are easy. Everyone should focus on getting these 2 points. Those are 2 free points, essentially. All right. Now let's go to FRQ 4. I'm kind of nervous because these are difficult. But let's see what we can do here. We have the functions h and g are given by these. First one says rewrite the g of x as a single logarithm, base 3, without negative exponents or any part of the expression. So we just want to take this, write it as a single log. I'm first going to take my coefficients and make them exponents. And then I know that when I'm adding logs, I'm really multiplying them. So it's really log base 3 x squared times x to the 4th. And we should all know that log base 3 x squared times x to the 4th is really just x to the 6th. So that's our answer. Log base 3 x to the 6th. I'm going to erase as I go here. You can always rewind the video if you needed it. Just so we have space. All right, this next one, rewrite h of x as an expression in which only the secant of x appears once, so that's important, and no other trig functions. So let's see what we can do here. I'm always trying to cancel things out. So I'm going to rewrite this numerator. I'm going to rewrite tangent as sine of x over cosine of x. And I'm going to rewrite cosecant as 1 over sine of x. Obviously, cosine's still on the bottom. So, okay, well, now these signs cancel. And I end up getting 1 over cosine of x divided by cosine of x. And when it starts to look weird like this, I tend to switch the notation to say, okay, I'm looking at 1 over cosine of x divided by cosine of x. And here's where I can do keep, change, flip, whatever you want to call it. Turns into 1 over cosine of x times 1 over cosine of x. This, I'm going to continue the workflow right here, turns into 1 over cosine squared of x. Well, what is 1 over cosine? That is secant. So I can just rewrite this as secant squared of x. All right. And again, I'm going to erase so we're just not overwhelmed with work. Oops. Don't erase the answers, though. Okay. All right, part B. Functions j and k are given. Solve for j of x equals 4 for all values of x in the domain. So let's do that. We get 4 equals log base 2 of x plus log base 2 of x plus 6. I'm going to start by simplifying my logarithm so that this turns into 4 equals, these are same base logs added, so I'm going to really turn this into multiplication. X times x plus 6, well, that's x squared plus 6x. And now to get rid of a log base 2, I'm going to do an exponential base 2. So I end up getting 2 to the 4th equals x squared plus 6x. 2 to the 4th is 2 times 2 times 2 times 2, which is 16, equals x squared plus 6x. Subtract 16 from each side. We get x squared plus 6x minus 16 equals 0. Factor this, I get x plus 8, x minus 2 equals 0. And we end up getting x equals negative 8 and x equals 2. This is where I have to be really careful. Remember, all logarithms must be greater than or equal to 0. So I have this x right here. So that means that all x values must be greater than or equal to 0. This also too, x plus 6 must be greater than or equal to 0. But we get x must be greater than or equal to negative 6. Well, obviously, if it's greater than negative 6, it also needs to be greater than 0. So I don't really need this. But it is true, based on this, that x must be greater than or equal to 0. X equals negative 8 is not inside our domain. So the only answer here is x equals 2. All right, I'm gonna erase all of that, clear up some space. All right, next one, we have k of x equals 7 for all values of x over the interval 0 to pi. So from 0 to pi, so I'm only looking at my unit circle from here to here, right? This first top part of the unit circle. That's important. So, okay, let's substitute in a 7. I'll use red. 7 equals 6 plus 2 sine squared of x. I'm just going to solve for sine squared of x. Minus 6 from each side. I get 1 equals 2 sine squared of x. Divide by 2. We get 1/2 equals sine squared of x. This is where, math is just beautiful, and we have to be good problem solvers. Take the square root of each side. We get the square root of 1 over the square root of 2 equals sine of x. Well, the square root of 1 is 1, so we get 1 over the square root of 2 equals sine of x. You'll notice that this is not on your unit circle because we have to rationalize the denominator. And when I multiply 1 over the square root of 2 times the square root of 2 over the square root of 2, I get, oh, there's something I recognize, the square root of 2 over 2. Well, okay, I'm just going to pull up a unit circle because ideally you will make one. And let's see. I think we all know, but just so you can see where we're referencing. Well, we're only looking in the parts where pi is from 0 to pi. So I'm only looking from here to here. So where's the only time we that sine equals the square root of 2 over 2? It's pi over 4. So we get pi over 4 here. All right, let's dive into this last part. C is always just one question, but worth 2 points nonetheless. Find all the input values for the domain. So we have an output of, oh, this one's scary. All right, so I'm going to plug cosine of inverse cosine equals -2/3 inverse sine. 5 square root of 2x. Okay. First thing, and you'll get a point for just doing this. Figuring out what this equals. Well, it's really saying what input to cosine makes the square root of 3 over 2. What input to cosine makes the square root of 3 over 2? Are we restricted on our domain at all? Oh, the arc sine is restricted inherently. Okay, so arc sine is restricted to this top part here. So we want to know, where does the cosine equal the square root of 3 over 2? Well, that's pi over 3. So we can switch this, and if you get this correct, this is 1 point right here, pi over 3. Let me show that one more time. What is it saying? Okay, what cosine outputs this? Because you're switching the inverse, or the input and the output. So that is pi over 3. And let me write a little smaller. Pi over 3 equals all of this. Now we get to do some more algebra. And this is a hard question. I'm going to divide each side by negative 2/3. And we get negative 3 pi over 12. And that simplifies to negative pi over 4. Yeah, this is hard. This is good. I mean, if you don't earn this point, I don't blame you. All right, negative pi over 4. So now I got to go back to the unit circle. Because I'm going to, well, before I go back to the unit circle, how do I get rid of inverse sine with sine to each side? So now I'm taking the sine of this. These cancel. The sine of negative pi over 4. That means I move backwards pi over 4. So I'm really taking the sine of 7 pi over 4, which is negative square root of 2 over 2, because sine is the y. I get negative square root of 2 over 2 equals 5 square root of 2x. So I just want to get x by itself to finish my algebra. I'm going to divide each side by 5 square root of 2. Divide each side by 5 square root of 2. We get x equals, I get negative square root of 2. On the bottom, I have 2 times 5 times square root of 2. Wow, this is just good algebra. I get negative 1. 2 times 5 is 10. X equals negative 1/10. Okay, I 100% lost some of you there. That's okay. But let's check our answers to make sure that I did all of this right. All right, we have log base 3. Yeah, we got that right. Just equals secant squared of x. Their workflow looks a lot different than ours, but that's fine. Look right here. X equals negative 8 is not in the domain of J. You only need the solutions to these, right? You don't need any, write the expression, write the solution. There's no explanation needed on these. Pi over 4 and 3 pi over 4. Did we get both of those? No. We didn't. So this, you need both. That's a mistake on my part. I would have lost a point there. And the last one, C, you get a point just for knowing that this is equal to this. And then you get a point for getting x equals negative 1/10. Okay, I know that last